Let's start with our second video in our series on fertilizers. In the first video, I gave you this problem. I gave you a bag of fertilizer and I asked how much nitrogen is present in 7 kilograms of this fertilizer. Now let's see, what information do we have? We know that 14% of this bag is our primary nutrients. We know that this ratio gives us the ratio of the primary nutrients, that is nitrogen to phosphorus to potassium. So in 14% of this bag, that 14% consists of 2 parts nitrogen for every 3 parts phosphorus for every 2 parts potassium. Okay, so the first thing that we're going to do is figure out how much is 14% of 7 kilogram. So, in order to figure that out, we take 14 times, or 7 times, 14 divided by 100 to get our percent. 14% of 7 is 7 times 0.14, which gives us 0.98 kilograms. Now we know that this 0.98 kilograms must be divided into the total parts that we have. So how many parts do we have in total? 2 plus 3, which is 5, plus 2, which is 7. So I have 7 parts in total, and I know that 2 of these 7 parts is nitrogen. So 2 out of 7 parts of 0.98 kilogram is going to be my the amount of nitrogen in the fertilizer. So 2 over 7 times 0.98 will give me 0.28 kilograms. Did that agree with your answer? Good. So let's continue with this video. We are creating fertilizers, and the first fertilizer that we need to create is ammonium nitrate. I get ammonium nitrate when I add ammonia to nitric acid. Here is my balanced equation for this reaction. If you look at it closely, you see it's not so difficult to figure out. If I take this hydrogen and add it over there, then I'll get from the ammonium, I will get the ammonia ion, NH4. And then I'm left with a nitrate ion on this side. So from my balanced equation, I see that I need ammonia and I need nitric acid. Ammonia I'm going to get from the Haber process. And in this video, we are going to look more closely, specifically at the Haber process. The next fertilizer that I need to construct is ammonium sulfate. And this I get by combining ammonia and sulfuric acid. Now I'm going to rewrite this equation slightly, and I think it will help you with the balancing. If I rewrite sulfuric acid as its ions, you see that I have 2 hydrogen ions and 1 sulfate ion. Now, if each of these hydrogen ions combine with 1 ammonia molecule, it will actually give me ammonium. So I have a hydrogen combining with this molecule and a hydrogen combining with that ammonia molecule. So as you can see, if I have 2 ammonia molecules and combine that with 1 unit of sulfuric acid, I will get ammonium sulfate, which has the formula NH4 2 SO4. So there's my balanced equation for this reaction. Ammonia we know already is produced from the Haber process, and sulfuric acid is made using the contact process, which we will do in another video. Okay, so let's have a closer look at the Haber process, which is used for the constructing or the making of ammonia. In order to prepare ammonia, I use nitrogen and hydrogen, and together they will give me ammonia. But as you see in this equation is not balanced. So let's quickly have a look. As part of my reactants, I've got 2 nitrogen atoms that give me a diatomic nitrogen molecule. But on this side, I only have 1 nitrogen atom. So I added 2 in front of the nitrogen, and now nitrogen is balanced. Let's have a look at hydrogen. On this side, I've got 2 hydrogen atoms combining to give me a hydrogen diatomic molecule. But on this side, all in all, there are 6 hydrogen atoms present in 2 molecules of ammonia. In order to balance this equation, I add a 3 in front of the hydrogen. So now I have 6 hydrogen atoms on this side for every 6 hydrogen atoms that I have as part of the products. How do I get the nitrogen and the hydrogen gas that I use for the Haber process? Nitrogen is made from the fractional distillation of liquid air. I remember when I was young, we used to learn that you need oxygen to breathe, and that always made me or led me to believe that most of the air is made of oxygen. And that is actually not true. Most of the air that we breathe consists of nitrogen, but since that is not really important for breathing, it's never emphasized. Okay, so what we do is we take liquid air and then cool it down really to very, very low temperature until it becomes a liquid. And then using distillation of this liquid, we can then get the nitrogen from this liquid air by heating it up to the boiling point of nitrogen. Hydrogen is prepared at Sasol using coal and steam to produce carbon monoxide, carbon dioxide, as well as hydrogen gas. In the Haber process, they combine these 2 gases to give us ammonia. This reaction is an example of an exothermic reaction. This means that heat is given off by this reaction. And if you remember Le Chatelier's principle, you'll remember that an exothermic reaction will produce the best yield at a very low temperature. However, a low temperature will lead to a very low reaction rate. So it will take quite long to produce ammonia gas. So therefore, the Haber process occurs at a slightly higher temperature, which compromises a bit on the yield. But since the reaction happens much faster, per day you will produce more ammonia than if you had a lower temperature. That concludes everything you need to know about the Haber process that is used for the production of ammonia gas. In our next video, we'll have a look at the Oswald process.